In this section, we are going to talk about relationship between zeros and coefficients of a polynomial. So let's try to understand relationship between zeros and coefficients of a quadratic polynomial. Then we'll talk about cubic polynomial, and then we'll look into examples. So let's start with relationship between zeros and coefficients of a quadratic polynomial. Let's assume alpha and beta are zeros of quadratic polynomial px equal to ax square plus bx plus c, where a is not equal to 0. Then you know that if alpha and beta are zeros of quadratic polynomial, then x minus alpha and x minus beta are the factors of px. Right? So they are going to be factor for that polynomial. And hence, we can represent ax plus bx plus c equal to x minus alpha multiplied to x minus beta and then multiplied to a constant number k, where k is constant. Right? So now if you try to break this, you can multiply these two factors together, and what you get is x square minus alpha plus beta x plus alpha into beta. And if you multiply all of them with k, it's kx square minus k alpha beta into x plus k alpha beta. Now if you try to equate coefficients of x square, x and the constant, what you get is a equal to k, because here ax square, when get equated with kx square, what you get a equal to k. Next, when you compare coefficient of x, you get b equal to k multiplied to alpha plus beta, with a negative sign, of course, right? So I get b equal to minus k multiplied to alpha plus beta, which then we know k is equal to a. So if I replace k by a, what I'm going to get is a multiplied to alpha plus beta, and c equal to k times alpha beta if you compare constant term, which is k alpha beta, to constant term, which is c. And now since we know k is equal to a, we can replace k by a, and then what we get is c equal to a multiplied to alpha and beta. And hence we can conclude from the first relation, alpha plus beta is equal to minus b by a, which is nothing. Minus b is coefficient of x and a is coefficient of x square. So this is alpha plus beta equal to minus b by a, which is nothing but minus coefficient of x divided by coefficient of x square. And alpha into beta is c by a, which is constant term divided by coefficient of x square. Hence, sum of zeros of a quadratic polynomial, how are they related to coefficients? So if I have two zero, alpha and beta, for a quadratic polynomial, then their sum is equal to minus b by a. So coefficient of x with negative sign divided by coefficient of x square. And next, the product of zeros, which is alpha into beta, is equal to c by a, which is constant term divided by coefficient of x square. Here is the recap. Alpha plus beta is equal to minus b by a, alpha into beta is c by a. So remember, sum of zeros is equal to alpha plus beta, and which is nothing but in terms of coefficients, if you try to see, it's minus b by a, which is coefficient of x divided by coefficient of x square. And the product of 0, which is alpha into beta, is equal to c by a, which is nothing but constant term divided by coefficient of x square. Now let's take a look of relationship of zeros and coefficient for a cubic polynomial. So let's assume alpha, beta and gamma are the zeros of cubic polynomial, and the polynomial is axq plus bx plus cx plus d, where a is not equal to 0. Then alpha plus beta plus gamma. So sum of zeros is equal to minus b by a. And product of 0 is minus d by a. And product of two 0 consecutively, like alpha into beta plus beta into gamma plus gamma into alpha, is equal to c by a. So ideally, if we check, sum is coefficient of x square divided by coefficient of xq with a negative sign. And the product is again minus coefficient of constant term divided by coefficient of xq. However, product of two zeros with a summation alpha into beta plus beta into gamma plus gamma into alpha is equal to coefficient of x divided by coefficient of xq. Now let's try some example. Let's try to find 0 of a quadratic polynomial x square plus 7x plus 10, and hence verify the relationship between zeros and coefficient for this quadratic polynomial. Now let's try to break x square plus 7x plus 10 into factors. And if you recall, what have you learned in class 9th for the polynomial is factor theorem. That's what we are going to use here. So we'll use factor theorem by splitting the middle term. And in order to do this, let's assume alpha, beta are the two numbers for which alpha plus beta is equal to 7. And alpha into beta is equal to 1 multiplied to 10, and hence 10. Now look into pair of factors for 10. And in this case, we can consider some of the pair of factors of 10 are 1 and 10 and 2 and 5. Out of which you will see 2 and 5 are such factors which if you combine and add them, what you get is 7, which is nothing but equal to alpha plus beta. And hence I'm going to consider 2 and 5 as the pair to be used for splitting quadratic equation or quadratic polynomial by factor theorem. And hence, here you go. X square plus 7x plus 10 get expressed as x square plus 7 get split as 2 plus 5 and then 10. And now x square, if I open this bracket, I'll get 2x plus 5x plus 10. If I simplify this by taking x out from the first two terms, I get x multiplied to x plus 2. If I take 5 out from last two terms, I get 5 multiplied to x plus 2. Now I can take x plus 2 out and I'll get x plus 2 multiplied to x plus 5. Hence, x square plus 7x plus 10 can be represented as x plus 2 multiplied to x plus 5. And now, the value of polynomial x square plus 7x plus 10 equal to 0 will employ when x plus 2 multiplied to x plus 5 is 0, and hence x equal to minus 2 or minus 5. Now, zeros of x square plus 7x plus 10 are minus 2 and minus 5. Now let's try to verify if zeros have some relationship with the coefficient of the polynomial, right? So if we look, sum of zeros in this case is alpha plus beta. By definition, it should be minus b by a, which is nothing but coefficient of x square, which is 1 here with a negative sign, divided by coefficient of x, I repeat, which is minus b by a. So coefficient of x, which is 7 with a negative sign, divided by coefficient of x square, which is 1 in this case. And hence, you will see alpha plus beta, which we got minus 2, and minus 5 equal to minus b by a, in this case minus 7 by 1, and you will see minus 7 is equal to minus 7, and that holds true. So if you sum two zeros, what you get is when you use coefficient of x divided by coefficient of y with a negative sign. Similarly, for the product, you will see alpha into beta as minus 2 multiplied to minus 5 is equal to 10 by 1, which implies 10 is equal to 10, and hence even this relationship is verified. Now let's take another example where we want to find a quadratic polynomial where the sum and product of zeros are minus 3 and 2. Now let's consider the polynomial as ax square plus bx plus c, and its zeros are alpha and beta. Then we'll have alpha plus beta is equal to minus b by a, and in this case what is given as minus 3. So alpha plus beta is equal to minus b by a for this quadratic polynomial, and what question has given as minus 3. So I have minus b by a equal to minus 3. And the product of zeros, which is 2, and by this polynomial if I look, alpha into beta is equal to c by a, and hence c by a is equal to 2. Now, if we consider a as 1, b as 3, and c as 2, then alpha plus beta gives you minus 3. Right? Why? Because you will do b, which is 3, by 1 with a minus sign will give you minus 3. And alpha into beta, which is c divided by 1, will give you 2. So, one quadratic polynomial which fits the given condition is definitely a equal to 1, b equal to 3, and c equal to 2, which gives you x square plus 3x plus 2. And we can find n number of such polynomial by multiplying it to a constant value k, where k is real number. Let's take another example. We want to verify 3, minus 1, and minus 1 by 3 are 0 of cubic polynomial px equal to 3x cube minus 5x square minus 11x minus 3. And then verify the relationship between the zeros and the coefficients. This is a cubic polynomial, right? So let's start. So we have the cubic polynomial as ax cube bx square plus cx plus d, and if I compare this cubic polynomial with the polynomial given, what we get as a equal to 3, b equal to minus 5, c equal to minus 11, and d is equal to minus 3. Further, we know if I try to find value for p3, because 3, minus 1 and 1 by 3, if they are 0, they are going to make this 0, right? So if I put p3, what you will see after simplification, it gives you 0. Same when I put p minus 1, after simplification you'll get 0. And when you put p minus 1 by 3, then also when you put them and simplify it, you get 0. So in all the three cases, 3, minus 1 and minus 1 by 3, they are all representing zeros for this cubic polynomial. And now let's take a look for, since these are the zeros of cubic polynomial, and if we consider 3 as alpha, minus 1 as beta, and minus 1 by 3 as gamma, what you get as alpha plus beta plus gamma is equal to 3 plus minus 1 plus minus 1 by 3. When you simplified this, what you get is minus 5 by 3, which is nothing but your minus b by a. Next, when you look into alpha into beta plus beta into gamma plus gamma into alpha, what you get is 3 multiplied to minus 1 multiplied to minus 1 by 3, and minus 1 by 3 multiplied to 3. And when you simplify it, what you get is minus 11 by 3, which is nothing but c by a. And same is for alpha, beta, gamma. When you put the values which you have considered here, the value what you get is minus of minus 3 by 3, which is nothing but minus d by a. Thanks for watching. You can visit us for more information on www.classesfun.com.